Okay, I just want to take a moment to go over the notes in case you missed them for today. We're talking about chemicals, properties, and changes. The major difference with the chemical properties and changes and physical properties and changes is that when we're talking about chemical properties and changes, we're talking about either the properties of a material or the way the material can change into something new. That is the key thing. Remember, in physical properties, you break a pencil, it's still a pencil. A chemical change, if I burn a pencil, that's now a pile of ash. It's changed into a new pile of material. Chemical properties. Chemical property is a characteristic of matter that can be observed as it changes to a different type of matter. So we really can't test a chemical property until we actually change something. So we see if it burns. Well, to do that, you have to burn it. To see if it reacts to oxygen or other materials, you actually have to let it react and change to see if it has that property. So again, we're talking about changing into something new. The ability of a fuel to burn is an example of a chemical property. The ability of iron to rust is also an example. Again, when fuel burns, when gas burns, it changes into new materials. When wood burns, it changes to material. If iron rusts, it's changed into a new material, iron oxide. Again, a chemical property shows that how a material can change into something new. Some chemical properties include how reactive it is, how flammable it is, when does it burn, where does it rust or oxidize. So different things like that. Uh, Remember, in properties, all matter can be described by using its physical properties and chemical properties. Our physical properties are those we observe without changing the material, just by looking at it or observing it. But a chemical property can only be observed by changing it. Does it burn? Is it combustible? Is it toxic? What's its acidity level? Does it react with water, acid? Does it rust? Those are different properties. Those are chemical properties. The difference in the types of properties is whether or not the matter changed identity while it was being observed. So if iron rusts, it's changed what it is. When you started with a cake, you had batter and you had eggs and all that stuff mixed together. But when you're done, you have a cake. It's actually changed what it is. You can't go back from this one. And that's another key thing about chemical changes. It's really hard to go back. You can't uncook an egg. It's really hard to unrot a banana. So these are chemical changes because they're changing into new matter. They're changing what's being observed, and you really can't come back from it. Okay. So again, a chemical change means that we are creating new substances. Chemical change is a change in matter in which a new substance that makes up the matter into that substance have new physical and chemical properties. So I think we've talked about like the salt. Sodium is a solid metal. Uh, Chlorine is a gaseous green gas. They're both toxic if you take them, but as they go through a chemical reaction and become salts, they become okay for us to tolerate. Um, so, chemical change is a change in which the new substance that makes up the new matter, change into other substances that have new physical and chemical properties. Okay, so new substances that are formed no longer have the same identity because they no longer have the same properties. So, as I was referring to, we have sodium, which is just a metal, silver metal. We have chlorine, which is a yellow gas, but you combine them in a certain way, you get table salt. Different properties, no longer silver, no longer a metal, no longer a gas. New properties because of the way the atoms and molecules have reconnected. There are some signs of chemical change. The release of bubbles or gas is a sign of chemical change, not always. Change of color can be a sign of a chemical change. Production of an odor when food goes bad, it starts to smell. That's a chemical change. Release of heat and light is a chemical change, and production of loud sounds can sometimes be a sign of a chemical change. The formation of bubbles is a chemical change. Now, it's not bubbles like in a boiling water. That is a physical change. But if I have bubbles from now, this is two substances mixing. It's copper with an aqueous hydrogen nitrate. It gives me copper nitrate, and okay, it gives me different. But what's happening is that bubbles, the process of them changing into new materials. One of them being gas. The way you can think about this is vinegar and baking soda is a good example of a chemical reaction, and it's indicated by bubbles. Energy is released during a fireworks explosion because a chemical change occurred. So the chemicals that are in the fireworks, when they are ignited with flame, they produce a heat, they produce a light, and different chemicals produce different colors. That's why the greens and the reds and the yellows, those are all different chemicals creating those different colors. When food rots, it changes in color and odor. That's not what I wanted. Sorry. So when food rots, it changes in color and odor and shows a chemical change has occurred. So if you're looking at an apple over time, we see that it decays. The apple decaying is changing into a new material. Okay, it's not the same material that it was because different materials have broken these things down, changed the chemical compounds in them, absorbed some things, let off waste products. They are two different materials. Now we see how cutting it has made the one react much quicker than the other one. And that has to do with surface area. We'll talk about reactivity in a little bit. But either way, not a fruit you're going to be eating anytime soon. Come on. Uh, these signs of a chemical change show that a chemical change might have occurred. They are not always the signs of a chemical change. Sometimes they are the sign of a physical change. Again, if I have bubbles in water, that could be a chemical reaction. That could also just be boiling. So we need to be careful about the fact that we are not just saying, well, it's bubbles. It's got to be a chemical change because it's not necessarily the truth. The only sure sign that chemical change has occurred is when we have a new substance. So they mix these materials together, they're going to blend differently, and in that blending, they're going to create a brand new substance and change. So that is a chemical reaction because I created a new substance. We're not going to go into great detail of these, but there are four main types of chemical reactions. There's a synthesis where you take two things and put them together. This is kind of like the salt being combined. So you have sodium chlorine becoming sodium chloride. We have decomposition where one material breaks down into two other materials. We have a single replacement and double replacement. You don't have to worry about that. We're not going to involve ourselves in solving these kind of equations. Um, there's also a kind of reaction called a combustion reaction. Combustion reaction always involves oxygen. All right, so another name for a chemical change is a chemical reaction. So, as you can see, when they add these materials in the little Erlenmeyer flask, yes, it's been animated to your enjoyment, but that is a kind of like elephant toothpaste. That reaction creates a change. Lots of gas, probably lots of thermal energy there, but that's a chemical reaction, chemical change. The chemical reaction occurs when atoms rearrange during a chemical change. So we have these reactants on the left, we have these products on the right. So when these things go through this process, we have what we start with. So sodium and chloride, for example, we have a chemical reaction, and then we have a new product. Okay, so this is actually burning of oxygen. This is like fuel burns. When we burn gas in our car, what we get is we have octane, which is the chemical ingredient in gas that allows it to burn very well. We have oxygen, which is necessary for combustion. When they go through react with heat, we end up getting carbon dioxide and water, some carbon monoxide, some other products as well. So that's kind of the way a car exhaust would work. Chemical reaction can be expressed by a chemical equation, which shows the chemical formula for each of the substances in the reaction. So here we have basically carbon dioxide and water combining. And I see what this is. This is photosynthesis. All right, so we have carbon dioxide and water. And these are the materials that we put into a plant, right? Plant needs carbon dioxide, needs some trace minerals, it needs this. Yield is the arrow that shows, okay, here's the reaction taking place. When we are done, we end up with glucose and oxygen, which are the byproducts. This is actually photosynthesis. This is what plants go through in their life cycle. They take in carbon dioxide and water. They exhale, they produce glucose and oxygen, which we can use. As we can see, everything here is over here. They just shuffle them around. An arrow indicates, so this arrow indicates that the reaction takes place. We also often say that the arrow means yields. So like this is the reverse process. This is kind of like for us, glucose and sugar. If we were to combine that and have a reaction, our products would be carbon dioxide and water. And again, every atom, we can count through these, every molecule, every atom of each element is present on both sides. Remember, law of conservation of mass, we cannot lose atoms in our process. We can shuffle them, can't lose them. The formula, the things on the left-hand side, we've seen this one a lot. This is actually, let's go back. This is actually methane. Methane is a gas that is a byproduct of decomposition. If you ever go by a waste management place, you might see a burning torch off on the side. What they're doing is they're actually burning off the methane. So the methane is CH4. Again, you have to have oxygen for a burning or combustible reaction. What you get is carbon dioxide and water vapor. So they take that methane, which is bad for the environment, break it down to carbon dioxide and water, which aren't as bad, not great, but carbon dioxide is a natural part. But the stuff on the left that's going to react are the reactants. The formulas to the right are the products. This is what was made. So if I have hydrogen and oxygen becoming water, the product is the water that was made. Now, chemical reactions must be balanced. We're going to focus this on Monday. We're going to do an activity with this on Monday. But again, law of conservation of mass. We cannot lose any atoms. They can move, we can shuffle them around. Whatever we start with, we end up with. We can't have leftover parts. We can't lose parts. So again, here's a methane molecule. You burn it with oxygen. You use a catalyst like a fire to spark it. What you get is carbon dioxide and water. But look, one carbon on the left, one carbon on the right. Four hydrogen on the left, four hydrogen on the right. Four oxygen on the left, four oxygen on the right. Everything that's on the left has to be on the right. They have to be balanced. Now, when balancing chemical equations, you cannot change the chemical formula of any reactant or product. So these you cannot change. These molecules that form naturally form. Now, there are ways to adjust that we'll talk about. We'll practice a little bit on Monday, but you can't break apart this NH4 just because it doesn't suit you or it's not easy to work with. This is the material you're working with. You have to work with it. You cannot separate the chemical formula apart. Remember, those are compounds. We can't separate compounds very easily. Now, if we do want to balance chemical reactions, we are sometimes going to have to use what's called a coefficient. Coefficient is the number that's placed in front of a chemical formula, and that tells me how many molecules I have. So you see how I have the 2O2. That tells me I have 2 molecules of O2. Okay? Now, there are some factors that do affect the rates of chemical reactions, and I will demonstrate some of these next week. Concentration. Obviously, if I am have a lot of acid, it's going to break something down a lot more than it would be with a little bit of acid. The higher the temperature, because molecules are moving faster, the rate of breaking down is going to happen quicker as well. What the reactants are, how tightly their bonds are together, what's our catalyst, what's causing this reaction to occur, and how much surface area is exposed. And again, a lot of these I'm going to review on Monday or Tuesday, and I'll do some demonstrations that show you kind of how these work. I might add some supplemental stuff as well, but all of these affect how fast or how quickly a chemical reaction takes place. Again, a higher temperature usually increases the rate of reaction because the particles are moving quicker. They're moving more quickly. So if they're bumping into each other more often, they are going to cause a reaction more often. Our amount of concentration is the amount of substance in a certain volume. Reaction rate increases with the concentration increases. So if I have a very light mixture of a material and I drop something in, it's not going to be able to break stuff down very well because those molecules are going to be pretty busy. But if I have a really concentrated mixture, I have a lot of those molecules that are going to be breaking down. The more molecules I have, the faster the reaction rate is going to occur. Surface area also affects the rate. At least one reactant is solid. Reaction rate is faster if surface area is large. So if I have like one block of ice, it's going to melt a little slower. Now again, melting is a physical reaction. So let's take an airborne tablet. Airborne tablets are ground little tablets. If I use the whole tablet, it's going to take a certain amount of time to break down. If I crumble that tablet into small pieces and increase the surface area that's exposed to the solvent here or the material, it's going to break down a lot faster. And again, I will demonstrate these things for you or just find a video that demonstrates these for you and share those with you as I can. All right, so those are chemical reactions, chemical properties. Again, the main thing about a chemical property, a chemical reaction is that it is demonstrating how a material or a property of a material that shows how it can change. Okay, it's going to change into something new. If it's not changing into something new, that's a physical change. It's a physical property. But if it does change into something new, that's a chemical reaction, signs of a chemical change. I hope this clarifies. I will attach this to the notes and I hope this makes you understand or lets you understand the information a little bit better. Have a good day.